not done exactly what I was hoping for. So is there one that was particularly fun or confusing, or was it all straightforward? It's too easy? I don't know. What was the biggest number you had to do? Or is this the wrong page? 19? So you did this one down here. Yeah, that one's not bad, is it? So yeah, let's take a peek at 19. Oh, just a minute. I think finally, welcome, Darren. I think that I can now show you my, yeah, let's see. Oh, I had someone complain about the homework not allowing them to upload the images or something. So I'll fix that. Let's see, Calc, this is 23A. Yeah, I can, here, let me just unhide, just a sec. So here, I'll show you. Yeah. So this is all from, yeah, this is all from the pandemic. So let's make available. There we go. Yeah, so now this is available. This is the answers, or at least my answers. So yeah, I could just show you this. So here, here's what I got. And you can see when they diverge and when they converge. Did this 5 years ago, so I guess we'll hope that it's right. So that one was a little bit more complicated, number 19. Let's see what I did here. So, so this, well, I say it's equal to 0, infinity, but so the deal here is that this stuff, it doesn't go to 0. So that's the problem. Here, maybe I should do it the way that I'm going to do it on the quiz. So give me a sec here to switch back to the iPad. But yeah, I've got answers. I'll make them available as we go along. But let's do it a shorter way. So up here, you're going to check 3 things. Number 1, let's see, what does the quiz say? Yeah. So just a minute. We're going to assume that you're looking at an alternating series. And so if you're looking at an alternating series, you're going to get rid of any alternating stuff. And you're just going to focus on the stuff that's non-alternating. That's this. Okay, there it is. So the 3 things, and I've got these actually listed here to remind you, is you want to make sure that this thing is positive. You want to make sure that this thing is decreasing. And third, you want to make sure that the limit as n approaches infinity is equal to 0. So we're going to check those 3 things. And if any of these, well, the main one is this one. If it is not decreasing, well, we could still use this perhaps. But so let's check these things. First of all, this is positive. There's no negative numbers there. Is this decreasing? Well, I don't think it is actually. So that would be a fail. But let's go to the very end here and talk about this limit. The limit as n approaches infinity of n to the n over n factorial. What does that equal? Well, that is going to be equal to n times n times n times a bunch of n's all over n times n minus 1 times a bunch of stuff times 2 times 1. So I just want to focus on these last 2 things, or actually just the last one, is you'll notice that each one of these, if we were to separate this into a bunch of fractions, each one of the fractions individually range from 1, n over n is 1. This is a little bigger than 1, this is bigger than that. But down at the end, you've got some numbers that are huge, n over 2 and n over 1. So for sure, this thing is definitely not going to 0. In fact, this thing goes to infinity. So because this does not go to 0, this is a no. So this thing diverges. So diverge. So on the actual quiz, you've got, basically I've listed these on the first of the 3. I've got 3 for you to do. That's all I want, is just check them off. Is this true? Is this true? Is this true? Positive, decreasing, and the limit. So I wanted to remind you of those 3 things. So let's just pick another one just to show you how this works. So this one here, I don't know if you had to do it or not, doesn't matter. So this one, the b sub n, the non-alternating part is n over e to the n. So is this positive? It sure is. Is it decreasing? Oh, I don't know. Let's find out. So that's going to be a little bit more challenging. You have to do this. How does n over e to the n, is this thing bigger than n plus 1 over e to the n plus 1? And if you multiply, I think you find that this is true. N times e to the n plus 1, is that greater than n plus 1 times e to the n? Let me double check. N times e is greater than n plus 1. Yes, that is true. As long as n is bigger than like 1. No, I think it's always going to be true. Yeah, by the way, I just canceled divided by e to the n. So this is true for sure. So e times n, that's 2.71828. Take any number, multiply it by 2.71828, you're going to get a number bigger than n plus 1. So that's decreasing. Number 3 is this thing, the limit as n approaches infinity of n over e to the n does equal 0. If you really want to know why, you can use the hospital. So L'Hôpital. Just do the derivative of n is 1, derivative of this is this, sure enough. Yeah. So this one converges, converge. So you're checking those 3 things. I don't know if you checked those things. You probably focused on this one. This is the biggie. Number 3 is the big one, but technically you have to check all 3. So I've got them all listed on here. So any other issues, questions, concerns? Yeah, what do you think, Eli? Oh, no, not necessarily. So here's the deal: is the alternating series test says if b sub n is positive and decreasing and limit equals 0, then converge. It doesn't say anything about what happens when those fail. So if it's not positive, well, if it's not positive, then maybe you didn't separate out all of your the negatives. Like down here, the sine of pi over n, that sometimes is positive, sometimes negative. So you'd have to deal with that issue. So yeah, generally, basically the whole positive thing is just saying get rid of all the negative stuff in order to use this. So in other words, get rid of this, you're going to focus on that stuff. Get rid of this, you're going to focus on the other stuff. And then the decreasing, technically we have to check that, and then the limit equals 0. But I know this is probably the focus of most of your homework as you were working on that limit. That was the hard thing. Yeah, so if these things are, if it's not positive, if it's not decreasing, then we don't know. Most of these, probably all of them are going to be positive, decreasing. Yeah, they're all positive. So you could always just check it off and say yes, yes, and pretend that you checked those things. But anything else, other concerns? All right, let's go ahead and try this out. You can do it. Let's see, 1, 2, 3, 4. There's 4 for the front. Just 1 for you. I don't know where this guy is. Here, I'll give you 3. You want 3 as well? Sure. I'll let you have those. Enjoy. 1, 2, 3. 1 for you. 1 for you. Sure. 1, 4 for the back row. Hopefully that's the right number. I think that's just 3. I'll give you another one just to be sure. There you go. Enjoy. Fair enough there. Good. No one's begging for one. All right. I'll put it on the screen for those who are watching from home. 26. Where did I put this? There it is. I just realized that it's not explicit here, but when you get done with all of this, you have to tell me, does this converge or diverge? So based on this, you'll say converge or diverge. See this one. Okay. I see some of you are hankering to give me your quizzes, so I'll take what you got if you have it, but don't panic yet. I'm not rushing you. You got it? Okay, good. I see a lot of writing. I don't like writing. That looks good. Minimal writing. You're just ready to go here. Nice. You like jazz? Like the jazz band and stuff? You're all set over here? Why not? No, you're meditating. Take your time. Yeah, take your time. Still a few people doing that. All set, Carson? All right. All right. Yeah. You like it? All right. Excellent. Of course, back row's always done first. Good job. Oh, looking kind of yucky out there. All right, very nice. Yeah, I see some of you are getting fancy. You don't need to get fancy, but I'll take fancy. You got fancy. I saw. Yeah, nice. What do you think? Slide it on over, looking good. Nice, check mark, I like it. Last one, you can do it. This one's the easiest of the bunch. Just put something down, take a guess. All set, still meditating, that's fine. I'll come back for it because we have a couple people who are still working. This one's done, this row. This is the more thoughtful row. All right. Oh boy. Does it look okay? It'll work. Good job. All right, I'm coming back. We're going to try to grab what you got. So put something in a box, converge, diverge, take a guess. Looking good, very nice, excellent, good work. Nice. Got something. You got something back here, good job. All right, nice. All right, excellent, well done. I think I got them all now. All right. Sure. Okay, let's do this. So let's take a look at these. It was hopefully, let me show you what I did so that you know what the minimum. I know that some people, they want to know what the bare minimum is. So the bare minimum for alternating series is you figure out what the term, the positive part is, and you're like, yeah, that's positive. Okay, so I've got it isolated. Now, honestly, here's how I do this. I skip the next question until last. So I skip that and I go to the bottom, and I say, oh yeah, we'll get to converge in a minute. I say, what's the limit? What's the limit as n approaches infinity? So let's go back up here. The limit as n approaches infinity of this is clearly 0. I hope you can see that without having to write down much. If you wrote it down, that's fine. But so here's the order that I do. I do this thing first, and this is kind of like 1a, you know, because you're basically just getting rid of the negative stuff. Then I do this second, and then the final thing I do is I check to see if this thing is decreasing. And this one is clearly decreasing. Anytime you just have a constant over something that's getting bigger, this fraction gets smaller. I suppose I could have spelled it out by writing it down, but this thing does decrease. And honestly, on a test, I'm happy if that's all you write. Okay, so if you're looking for the bare minimum, that's fine. And then, okay, this thing converges. Let's take a look at the next one. The next one is a little different because this one actually doesn't converge. And so you'll see I do less work to do this one actually. So here's what I did is I first of all figured out what B sub n was. And I said, hey, that thing is positive. So this thing is positive. So, I mean, that was the whole point. I suppose you might argue that when n equals, I've started 5, so I'm fine. So I don't have to worry about that negative because you plug 5 into this, you're never, any number bigger than 5, that negative 5 isn't going to make this negative. So this will always be positive. We're good with that. Then I go down to the limit. That's the next thing I do, is I do the, there it is. So I do the limit, and the limit of that thing is actually 1. So once I figure out that the limit is 1, I don't do any more work because this thing is going to diverge. So that diverges. So that's sort of the order of operations for me, even though I've written it in that order. So here, I'll do this one. So first thing I do is I write down this. Okay, this thing is positive. I did make a note here. This is decreasing because it is. Anytime you have a constant over something that's getting bigger, the thing that's getting bigger is going to make this thing overall get smaller. So I kind of cheated, but, well, I didn't cheat. I just wrote that down. technically, though, all that you really care about is that this is bigger than 0. Then you look at the limit. And if that limit is 0, then you worry about decreasing. So here's the order that I would do this in. I would do this first, then this, and then this. And then, of course, the conclusion is that it converges. So that's sort of the way that I did these. And yeah, I know, way less writing than most of you, like most of you. And I know maybe you were worried that I was going to force you to write down why it is, but I think that we can, we're all among friends here. We can just sort of like say, okay, these are, if it's a constant over something that is like a polynomial or anything bigger than a polynomial, that thing is going to decrease. Like constant over, like this one as well as the first one. Constant over something that gets bigger, that's a decreasing function. Okay, let's move on. So today we're going to be adding these things up. In particular, I'm interested in this series. So here, let's do this one. This is an alternating series. So n goes from, let's see, how do I want to do this? I always change up. Let's do it like this. So 4 times -1 to the n over 2n plus 1. We'll do that. Okay, so what is this? Well, here's what this is. This is 4 minus 4 over 3 plus 4 over 5 minus 4 over 7 plus 4 over 9 minus 4 over 11, etc., etc. Now, interestingly, this series is related to my favorite derivative. So this is actually a series representation for the arctangent. And so because of that, and because I've cleverly chosen the numbers I'm going to plug in, we'll deal with, after the next test, we'll deal with functions and representing a function as a series. That's the goal of all of this, by the way. But anyway, getting back to this happens to be related to arctangent. And so this is actually a representation of pi, that the sum of this is pi. So kind of interesting. Now, what we're going to be doing today is we're going to ask, how close can we expect to be if we, because we're not going to add up all of these. So let's say that I start adding 4 minus 4/3. Let's see, I'm down to 2 2/3 plus 4/5. Now I'm at a little over 3. Then I lose some ground. Then I gain some ground, and I lose some ground. If I keep doing this and I stop here, how close am I to the truth? The truth, of course, is pi. How close am I to the truth if I stop there? Well, it's actually a pretty simple answer, and some of you probably can guess what the answer is without me actually going through this, but let's go through this rigmarole here. Here it is. So the alternating series, if you, let's see, we've already done this, never mind. So we've got this, okay. This is what we're doing. We're estimating sums. So I want to know, how close am I to the truth when I stop after, because we're never going to add up an infinite number of these terms. So I want to know how close I am to the truth when I stop at a certain number. It's kind of similar to what we did with the, what is it called? The integral test. You remember, if you stop at a certain point, how close are you to the truth? Well, you can approximate how close you are to the truth. So here's the deal, is if you stop, then you are as close, well, the next term, that's how close you are to the truth. You see, here's the deal. I mean, it's pretty, hopefully it's pretty obvious what's happening. I'll rewrite this. 4 minus 4/3 plus 4/5 minus 4/7 plus 4/9. Okay, let's just go that far. And here I will actually succumb to using a calculator. Give me a sec. And let us write down the partial sums of this series. Incredible. Okay, there we go. It's ridiculous. Okay, clear this out. Okay, so I have 4 minus 4/3. Jot this down. And so here's what I'll do is I'll start with 4. That, of course, is just the first term. When I subtract off 4/3, I get 2.667. I'm only going to go to 3 digits. You'll see why in a bit. Then I add in 4/5, and I have 3.467. And then I'm going to subtract 4/7, and I get 2.895. And then I'm going to add 4/9, and I get 3.339. Technically, it should be 3.34, but who cares? So the question is, how close is this to the truth? Now, of course, we know what the truth is because I told you what the truth is. For this series, the truth is pi. So you could say, oh, well, you're within 0.2 because pi is 3.14. This is 3.34. So you're within 0.2 of the truth. But you see, if you're adding up terms of an unknown series that alternates, you're not going to know what the truth is necessarily. And so you want to know how close could you expect to be to the truth? Well, the idea here is that the next term, first of all, each time I add or subtract a term, because these are decreasing, you're getting closer to the truth. You're just bouncing up and down. Maybe this picture is good, this one here, for just a sec. So this is the sum. Yeah, this is the sum. So notice that the truth is in the middle. You're going down, then up, then down, then up, then down, then up. And each time you either go down or up, you're going down or up by whatever the next number is. And each time you're getting closer to the truth. So worst case scenario, when I'm up here, the next term is going to send me down here. And maybe that is the truth. Now, it's not. But that's the very worst it could be, is that it could be the difference between this and this, which is the next term in the sequence. So that's basically it. That's all you have to do is the next term. So if I stop there, how close am I? Well, I am definitely, this is going to be within, oops, change colors. This is within 4/11 of the truth. That's it. That's all we need to know. We're done. Well, we're not quite done. So using this knowledge, how many terms do I have to add up to be within 1/100th? So there's a new challenge. How many terms so that I am within 1/100th of the truth of pi? Question mark. Get rid of that. Take a minute, see if you can figure out how many terms do you have to add up to be within 1/100th of the truth. And I don't have a lot of room here, so I'm going to have to back off and figure out a better place to put it, but see if you can figure it out. It might help if I show you the formula again. Where's the formula? Is it here? Yeah, there it is. Okay, yeah, I'll just do it. I'll do it. So I want to be within 1/100th of the truth. So where am I going to cut off? Well, here's how we're going to do this. I want the next term, 2 times n plus 1 plus 1. I want that to be less than 1/100. Because the next term, wherever I cut it off, the very next term it tells me how close I am to the truth. Theoretically, so this is like worst case scenario. I realize that I'm really a little bit closer than this, but that doesn't matter. I want to be sure that I'm going to be within 1/100. So let's solve this inequality. It's not hard to solve, cross multiply. And since I'm multiplying by positive numbers, I don't have to worry about weird stuff going on with the inequality. So that means that 2n has to be bigger than 397, which means that n has to be bigger than 397 over 2. And so let's just pick a number that is bigger than 397 over 2. 199 is bigger than 397 over 2. If I add together 199 of these, which is that's a lot of them, I will only be within 1/100th of the truth, sadly. I should have had this set up on Python. I'm not going to bore you while I type things in, but I will do this, which is relatively easy to do, and that is to set this up in Excel. So give me a second here. Here we go. Okay, ignore that over there. I don't know what's going on. Hold on a sec. So yeah, this, if you haven't figured it out, you can use Excel for this sort of thing. Let's see, I don't care about this. Okay, so let's do this. 1, 1, 2, and we'll just copy this down. Hold on a minute. How many did I need? 199? Okay, 199 of them. Let's go down to 199. Hold on a sec. There they are. And so let's get our terms. So let's see, the formula was this equals -1. Oh, I start at 0 though. Hold on a sec. I got to slip another term in. Just a sec. Slip another term in here, or another insert. There we go. Sorry, I started at 0. I didn't start at 1. Okay, so this is going to equal -1 to this power. Give me a sec here. Times 4 divided by, in parentheses, 2 times this plus 1. Okay, so you start with 4. Let's just double click this little thing here. There we go. So you have 4, then -2 4/3, then +4/5, then -4/7, etc., etc. Well, let's go ahead and add up all of those, equals the sum of everything in column B, and we get 3.136. Certainly that is within 1/100th of the truth, is it not? 3.14159. So it's actually within 0.005 of the truth, but it still is not that impressive. Let's see how far we have to go. Can I just keep going with this thing all the way to the end of the sheet? Hold on a sec. Let me see if I can, what if I go all the way down to the bottom? How many is that? Can I, oh, wait, what did I just do? Down? Oh, it just copied 198. Hold on a minute. How about this? If I do this equals this plus 1, there we go. And then I'll just copy that down to the bottom. There we go. And then, oh, it's taking its time. It's got to, oh, why did, okay, it's just taking its time. And then I go down, copy this to the bottom. Did that copy that down? Oh, no, it didn't. Hold on. Copy this down. There we go. Now I've got, is that like a million terms? How close am I to pi now? 3.14159. 2. Oh. Okay, so I got 6 digits. That's pretty good. Well, with a million terms, it's not all that great. But anyway, so you can see this particular series does not converge very quickly. It's really pitiful, to be honest. So hopefully we can find some series that are better than this. Let's take a look at this one. I want to find the sum of this series correct to 3 decimal places. Now, I will tell you the answer to this in just a minute. I know what the answer is supposed to be, but what I want to know is I want 3 decimal places. In other words, oh, first of all, this is an alternating series. This does converge. So we've already gone through all of that rigmarole. I want to know, what do I need to make in so that this is less than 0.001. That's what I mean by 3 decimal places. Go ahead and see if you can figure this one out. And I will get the correct answer in just a minute here. There it is. Okay, I've got the correct answer. Let's find a volunteer. Nice. Not here, of course. Ooh, did I lose anything? All right, so Braden, I know you have the answer back there, but don't tell me yet. Just tell me what you want me to do to get closer to the answer. What's the first step you're going to do? Okay, you're going to guess and check. That works. I was going to make it a little bit easier before the guessing and checking, but yeah, that's the second step. Let me do the first step for you then. The first step, I thought the easiest thing to do would be to reciprocate both of these, because really this is 1 over 1,000, and this is 1 over n plus 1 factorial. So essentially what I want is I want n plus 1 factorial to be bigger than 1,000. I just thought that that would be easier to do than doing a fraction. But no, guessing and checking is actually the right thing at this point, because I don't know how to solve that. Well, there's a way to solve it, but we're not going to deal with that here. And so let's just go ahead and guess and check. So let's see, n plus 1 factorial. Let's say n is 5. N is 5. 5 plus 1 is 6. 6 factorial is 720. Okay, that didn't work. Let's try n equals 6. N equals 6. 6 plus 1 is 7. 7 factorial is 5,040. That works. There you go. So yeah, guessing and checking is fine. So when n equals 5, it's a no. N equals 6 is a yes. So n equals 6. That's how many. So let's go ahead and do it. On my calculator, I'm going to do 1 over 0 factorial. By the way, 0 factorial is 1. You can check. Your calculator knows this fact. If it doesn't know that fact, then it's wrong. Then you're going to, let's see, subtract off 1. I know. Then plus 1 over 2 factorial, that's 1/2, minus 1 over 6 factorial, plus, or I'm sorry, 3 factorial, which is 6. 1 plus 1 over 4 factorial, which is 24, minus 1 over 5 factorial, which is 120, plus 1 over 6 factorial, which is 720, which I know if you don't have memorized, you could figure it out yourself. But I'm a combinatorialist, so I have this stuff memorized. So if I add these up to 6, I get, let's see, negative 1 to the n over n factorial. I end up getting 0.368. Oh, wait a minute. Do I have, oh yeah, that's good. Okay, so 3681, just to get the next digit. Now, here's the truth. You want to know what the truth is? And once again, after the next test, we'll be learning how I know that this is the truth. It's not hard. But the truth is that the answer is 1 over e. And 1 over e, if you do it on your calculator, I did it earlier, is 0.367879. And look, we are within 0.001 of the truth. So we did it. We're happy. Okay, let's do the next one. So go ahead and take a minute and see if you can work this one out. How many terms do you need to do to be within 0.00003 of the truth? So I think you're getting the drill here. By the way, in each of these cases, before we get going, we would have to do the alternating series test to make sure that this actually converges. So we would want to do this. N cubed plus 1 is greater than 0. It is decreasing. And the limit as n approaches infinity is equal to 0. So we're all done. Let's just pretend that we did all of that already. So now your job is to figure out how many terms do I need to get to get within 0.00003. Okay, let's see how we did this. So who gets to do this? This is so much fun. Don't worry, I'm not going to make you do the whole thing. Karen, what do you want to do? What's my first move on this thing? So the error. So what is the error when I stop? So in other words, I'm stopping at a certain point. What's the error for an alternating series? So like here the error was so the error is like what I got when I plugged n plus 1 in there. Here oh yeah, I didn't do that. So the error is the next term. So you just do the next term. So we're going to take this, add 1 to n. That's the error for stopping after a certain number like n. So yeah, so just take that term, take this stuff, and plug n plus 1 in. So n plus 1 over n plus 1 cubed plus 1. Okay, so that's the error. Now I need an inequality with this error. Maggie, do you know what I'm going to make my inequality, how this is going to look? Oh, this thing, yeah. So I think it's 3 over 10,000. Is it 10,000 or just a minute? Tenths, hundredths, thousandths, 10,000ths, 100,000ths. Okay, yeah, it's 100,000. You got it. You were right. I was wrong. There we go. So I've got that nightmare to deal with. Okay, let's see. We can do this, can't we? Let's cross multiply. I've got 100,000 n plus 100,000 is less than 3 times n plus 1 cubed plus 3. Couldn't I just like move everything to one side? Yeah, we could do this. Let's move this stuff over. So I have 3 n plus 1 cubed minus 100,000 n minus 99997. And then you're going to factor that? Yeah, I think Desmos is going to factor that. Okay, so let's pull out our Desmos or whatever, and don't be shy if you need to use that. I think the ones on your homework probably won't be as nasty as this. So I happen to have this mostly typed in. So give me a sec here. Oh, I typed plus instead of minus. Give me a sec. Okay. Okay, so I got a nasty, it doesn't factor, sadly. And I got something ugly when I said solve this. And so, yeah, it's 56 point, here we go. So this means that n is bigger than 56.7. Yeah, that wasn't very satisfying, was it? But technically you could do this if you were willing to use your calculator. So that's another thing, is you could use your calculator because your calculator has like a root finding. You know, if you type the function in, I don't know, we haven't really spent a lot of time with the calculators, but if you're familiar with this, you can do it. You can use Desmos. I don't know how much on your homework is going to be as complicated as this, but this gives you the place that you need to stop. We need to be more than this, so 57. I'm not going to do 57 terms of this. That will be too much. And I don't know offhand what the truth is for this one. We can figure it out after the next test. All right, we have, is this one more? Is this one going to do it? Yeah, let's do this one. This one will be fun. Yeah, this one I happen to know. I know that one. I know this one as well. How fun. Okay, I know this one. I know what the answer is for this one. So let's do this one. This one is going to be fine. 4 decimal places. See if you can set this one up. And by the way, in each case, you'll just have to trust me. I've done the alternating series test. This qualifies, this converges. So we can do this little trick that we're about to do. Oh, let me get the true answer so that we can compare. Okay, good. Ooh. Okay. All right, let's see how we're doing. I mean, once again, we'll set this up, and then we'll do the solve. So Michael G. Michael, what is it that we're going to compare to? Like, what is the term that we're using? Oh, like we're going to set up an inequality. Okay, very good. And so remember, that's the term. And so we want to do the next term. So whenever we do this, pardon me, what we want is we want the next one. The next one is going to be 2 to the n plus 1 over n plus 1 factorial. So yeah, so you take that term, the sort of generic term, the one without the negative, and then add 1. And then this is what we're going to compare this to. So we're going to compare this 4 decimal places is 10 thousandths. So 10 thousandths. There we go. So let's just go ahead and cross multiply here. 10,000 has to be less than 2 to the n plus 1 times n plus 1 factorial. This is another one that you're just going to guess and check because this is too complicated to solve. We haven't learned how to solve these things algebraically. It's not an elementary solution that we're going to do. But see if you can figure out, when does this get bigger than that? It's not going to be a big number. I'll just tell you that right now. I wonder if my computer can do it. I'm curious. Oh, no, it can't. Well, at least mine can't. So I guess I'm stuck just guessing and checking. All right, so let's see. Here we are. So take at least one guess, even if it doesn't work. Oh, you got something, Hayden? All right, so your guess is 5. So let's do this. N equals 5. And then we'll do 2 to the 6th times 6 factorial and see if that is bigger than 10,000, which I think it is, but let's double check. So 2 to the 6th is 64. 6 factorial is 720. And so that's 46,000. 46,080. So that makes me happy. But let's just double check, because that might not be the very smallest number. Maybe if we stop at 5 or 4, it'll be fine. So let's check. Let's check 4. N equals 4. I'll just do this. I have 2 to the 5th times 5 factorial. That's 32 times 120. Not quite enough. That's 3840. So sad. But this one works. So n equals 5. That's how far we're going to go. So let's actually compute this. This isn't too hard to do on our calculators. We start with -1 over, let's see, 2 times 1 factorial. That's just 2. And then we're going to do -1 squared, which is 1, over 4 times 2, that's 8. And then minus 1 over 2 to the 3rd is 8. 3 factorial is 6. So 48. We're just going to 2 more terms. We're going to add these up, though. And then 1 over, this one's positive because it's -1 to the 4th. 2 to the 4th is 16. 4 factorial is 24. And this, I could probably do if I thought about it, but I'll just do this. And then we've already done this one. So this will be minus, oh, interesting, 3850. Or 40. It's just 10 times the other one. Okay, let me do this on my calculator, and then I'll tell you what the truth is. Well, I'll tell you do it on the calculator and I'll tell you the truth. So this is negative 1 over 2, whoops, plus 1 over 8, minus 1 over 48. So you could do this yourselves, 1 over 384 minus 1 over 3840. And I got negative, it's negative 0.393489. Good enough. Okay, so the truth is that this, and once again, after our next test, you'll be able to look at this. Okay, some of you are going to be able to look at this and know what the correct answer is, like I'm doing. The correct answer is sorry, not 1 minus, hold on a second. It's e to the negative 1/2 minus 1. That's the correct answer. And that is approximately, I had this just a minute ago, but it's disappeared. Oh, there it is. Let's see, there is negative 0.393469. Incredible. This is off by just 200 thousandths. So this not only gets us to within 1/10,000th, it gets us to within 200 thousandths. This is super close. So anyway, yeah, like I said, after the break, or not after the break, after the test, it's really exciting that I can look at something like this, or okay, whatever, yes. Or like this and say, oh yeah, I know what that is. That one is natural log of 1/7 minus 1, I think. Yeah, there's a weird thing because we're not starting at 0. Or no, natural log doesn't start. So I think it's like the natural log of 1/7 or something like that. But once again, it's because, after the break, we'll see that these things actually relate to actual functions. And functions, you can represent them as series, and then there's all sorts of cool things we can do with this. Okay, but let me see if there's anything else that we need to do. How much time do we have? We're almost done. I think that this is it. Yeah, okay. This is good to just note. You remember we did the integral test. In the integral test, when you had a function that satisfied the integral test, you could approximate the sum of an integral, of the series using the integral test, and you could say how close you were. And the same thing is true here, that you can approximate the sum of an alternating series, but this only works if you can apply the alternating series, like if it's an alternating series. So that's why earlier I was like, well, technically I should have done this each time. I should have said, does this fit the alternating series test? So this has to be bigger than 0. It's decreasing. This limit is 0, and you have the -1 to the end there. So as long as all of that is true, then you can do this to approximate the total. So anyway, it doesn't work with other series, just with alternating series. All right, so hopefully the homework for tomorrow, I'll try to update for those of you who are complaining that I've changed the rules and now you've got to have PDFs and you guys can't figure out how to make a PDF, even though it's really easy. So I will change it back to taking images. In fact, I'll do that right now, and at least for the first couple of homeworks. Let me stop the recording if you want to come chat. Otherwise, I hope you have a good day. We'll see you tomorrow.